Good morning, everyone. This is Gunjan Goel. I would be taking your R classes or the paper B classes for both CS1 and CS2. So yes, first things first, most of you would be just starting with CS1 and don't know how to use R. So first, today we learn how to install R and RStudio on your computer, and then we will move on to the classes of R. So in Google, all those of you who are here, we would need an active present connection, internet connection for you to start with. Please write download R. Download R on your Google. I hope my screen is visible. So download R on your Google Drive. Download R on Google and see, please open the first link. Open the first link on your screen. Open the first link on your screen and click on the first link. This download R 4.2.1 from Windows. A file will start getting downloaded. An exe file will start getting downloaded on your system. Let it download. Let it download on your system. Once the file is downloaded, click on this and open it. Once the file is downloaded, click on it and open it. Something like this will open up. Something like this would come on your screen. Do you want to allow this app to make changes on your device? You will say yes. Okay, please click on yes. And then whatever defaults are there, just keep on going on next, and press yes. Keep on clicking on next and press yes. Okay, please tell me when you all are done. Please let me know when you are done. We'll move to the next step then. Okay. Next, again, once you're done with R, now again on Google, please write, again on Google, write, download R Studio. Download R Studio. So again, open the first link on your system and you would see R Studio Desktop. R Studio Desktop. Click on download and again a file will start getting downloaded on your system. Okay. Once you download it again, just install it the way you have installed R by just clicking next and so on. Please write download R Studio on Google. Click on the first link. When you somehow this is not working. You write download R Studio. You get the first link. The first link will open. You would see R Studio Desktop. Click on download. This again, this box will open and click on download R Studio for Windows. A file will start getting downloading. Please let me know once you are done. Done. Shall I proceed with the next one, please? Okay. So once you see, you will see R opens up like this and RStudio opens up like this. Why did we install both? Because RStudio will not work without R. Okay, RStudio will not work without R. RStudio is just a skin over R. So basically, when you see the R window, R is just a black and white screen, or I would say blue and white screen with no other color on it. Whereas RStudio is a fancy screen, a more graphical interface for users to use. Okay, we'll be mostly using RStudio for our classes now. Now, first thing first, R is a programming language. Okay, one thing you need to understand that R is a programming language, and there is nothing and the programming language has been built into a software where we can download the software. But if someone asks you whether R is a programming language or R is a software, it is a programming language. Okay. So currently in the industry, there are lots and lots of data available in any store. Starting from a small grocery shop in your locality to a MNC company or to any hospital, to any police station, to anywhere in this world, data is major. There are a very, 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 very huge amounts of data which are flowing in between us together. All this data needs to be stored and they need to be analyzed. The storing of the data is generally done by Excel, SQL, mostly SQL because it's a database management system. And there are other such means of data storage systems available, whereas the analysis is done by either Excel or the statistical softwares and languages which we have, like R, like SAS, like Python. All these do the analysis part of the data. We just can't store data and keep it into our books. We need to understand that what this data will provide us for future, what these data can tell us for the future, what are the trends in the data, what are the non-trends in the data, which type of data can be stored, why these data has been stored. All these can be done into an analysis by these softwares. Now, R is a free software or a free programming language. You could download it directly from Google and you can use it. Whereas others like Python or SAS, these are paid softwares and one cannot download without having any license to it. Okay. Moving forward, first thing, what does RStudio show? So there are 4 screens in R. This is called the script where you will write all your codes. This portion, the above portion, is where you will write all the codes. This is the portion where you would write codes. This is the portion called the console. This portion is called console, where you would get the output. Okay, this is where you would get the output. This area is generally used for plots. We would see all sorts of plots we plot being displayed in this area. And this is the global environment which stores all the codes you have run till now in the global history of R. Not you of your use, but R keeps a history and track. Whereas all these are these areas for plots, and the most important areas are these two, where you run your codes and we get your answers. 1 second. Now, please please note two commands that you'll be using. Control enter. Control and enter is for running the codes. Control enter is for running the code. And control and control plus L is to clear the console. Control plus L is to clear the console. Is that okay to everybody? Is everybody okay till here? Please at least tell me a yes or a no, please. Okay. Now moving on to the operations. So if I write 5 minus 2, if I write 5 minus 2 and press Control Enter, see it gives me an answer 3. So how do you run your codes? 4 plus 5, 9. That is, you write and you press Control and Enter together. 6 into 15, Control Enter together. Okay, which is 90. Is that okay with everyone? Now, are all these answers are currently just being displayed and they're not stored. How do you store your variables in R? Is you write A, and now R is case sensitive. If you write capital A, you have to use capital A. If you write small a, you have to use small a. Okay. If I write small a and a less than sign with a hyphen, a less than sign with an hyphen, and write A is equals to 5 and run Control plus Enter, and then you just run A. Just select A and run. So see, A will display 5. A will display 5 for you. Okay. Similarly, you can store B as 10, and then A plus B can give you 15. Okay. A plus B can give you 15. Is that okay with everybody? Next. Yes, I'll do that again. I just wrote A plus B and pressed Control Enter. Every time you write any code in R, you have to press Control Enter so that it gets run. If you want to just show it, display the value of A, then you need to select. Otherwise, you can just run it. R will run the entire line for you. Okay. Now, how to create vectors? Creating vectors. So, different ways. First way to create vector is A of 1:5. 1:5. 1:5. This will give me all values of A from 1 to 3, 4, 5. A is equals to 1:5 means A will give me values from 1 to 5. Storing consecutive numbers. Okay, storing consecutive numbers. Then the other way is using concatenate. C. If you do not want consecutive numbers, you want numbers like 2, 4, 6, 2, 4, 8, 9, 7, and so on. Then you use a C, concatenate. Okay, we'll use C in R to get all these numbers together and press a Control Enter. So see, B is 2, 4, 8, 9, 7. The other way of creating a vector is using the sequence function. It is using a sequence function. Say D is equals to sequence of 2, 10 and y is equals to 2. I hope everybody knows what is AP series, arithmetic progression, or a series with a common difference. So sequence function here creates a series, AP series. Okay. So if my D is equal, if I want a series from 2 to 10 with a difference of 2, so I'll write 2 to 10 with a difference of positive 2. And if you run D, then you see that D is 2, 4, 6, 8, 10. D is 2, 4, 6, 8, 10. Okay. The other way to create is repeat. So E is say repeat. Repeat 6 5 times. Repeat 6 5 times. Repeat 6 5 times. So it will give me 6 6 6 6 6 5 times. Okay. And then we have, if I want two numbers, repeat 1 and 2. Repeat 1 to 2. Each is equals to 4 times. Each is equals to 4 times. So see, F becomes 1 1 1 1 1 2 2 2 2 2. Okay. if you want to create a vector of, names, say G is equal to name, then how do you write? You write each name in inverted commas. That is Raghav, then you write Gaurav, then you write Kritika, say Rupali, say Naman, Astha, and so. Okay, and you run G. See, all these will get run. But these are again text. You cannot write names without inverted commas. Okay, you cannot write any undefined character in R without inverted commas. Okay, now we'll see the property. How do we see the property of vectors? A property of vector is seen using the class function with a small c. Class with a small c. Okay, it will show us the class of an object, the property of an object. So if I run class of B, see it is numeric in nature. Whereas class of G is character in nature. That means all values are your character and all values in B vector is numeric in nature. Okay. If I have a mixed character, say 1, 2, 3, Raghav, Gaurav. Okay. If I have something like this and you run H, see the numbers also become as characters because characters take precedence over numbers. Characters takes precedence over number when we deal with vectors. So then class of H will also become character. Class of H will also become character. Okay. Class of H will also become a character. Now let us do vector functions. Vector functions. How does vector functions operate? Suppose there's a vector T, C of 10, 5, 19, 35, 67, 2 and -1. Okay. This is a vector T. Now I need to sort this vector. What do I mean by sorting? Arranging it in either descending order or ascending order. Okay. So if I need to sort this vector, which function do I use? Sort. There's a direct function called sort. If I write sort of T and run it, so see it is by default arranged in ascending order. Default is arranged in ascending order. For arranging it in descending order, I need to write decreasing is equals to true. Decreasing is equals to true with a capital T. Sort of T, comma, decreasing is equals to true, which arranges this in a decreasing order or in a descending order. Okay. If I want the opposite of the vector, say I want the reverse of T. I want the reverse of T. I will write rev of T. Rev of T. So see, it gives you the vector in a reversed order. -1, 2, 67, 30. Just the reverse order of the vector. Okay. Now suppose you have a vector K where you have, say, Suppose this is a vector, a complicated vector which I have created, nowhere it is given. Okay, this is some vector. And I tell you to draw a frequency table of this vector. I tell you to draw a frequency distribution of this vector. How will you draw? You will try to break this that, okay, 5 is there 10 times, 4 is there 5 times, then there is 5 again, there's 6 again. And you will try to arrange all the numbers and then you will try a frequency distribution. R does it for you in one go using the table function. If I write table of K, if I write table of K, so see, R gives me a frequency distribution which says 0 is 5 times, 2 is 1 time, 3 is 1 time, 4 is 5 times, 5 is 12 times, 6 is 3 times, 7 is 9 times, and 8 is 1 time. This is how you get a frequency distribution. Okay. And the last one is unique of X. Unique of K. If I do a unique of K, it will only return me the unique numbers. Unique of K. Sure, I will repeat. So basically, I created this vector which there were a lot of numbers. Okay. I hope everyone has done tally in school where there was a tally distribution where you used to cut numbers like this. Let's suppose if I break this array, say, that means K becomes what? C of 5, 5, 5, 5, 5, 5, 5, 5, 5, and so on. Similarly, 4, 4, 4, 4, 4, 2, 3, 5, and 6, 7, 8. And to draw frequency distribution table, how you do? You write 5, 4, 2, 3, 6, so on. About how many times 5 is coming? 1, 2, 3, 4, 1, 2, 3, 4, and 5, right? And similarly 1, 2, 3, 4, 5. So this, instead of doing this manually, using the table function, R directly calculates the frequency distribution for you. Yes, every time you need to get a frequency distribution, you have to use the table function. Okay. Is that clear? Is that clear, Sunil? Is that clear, Sunil? Huh. Okay, and unique function basically will return you the unique values in an array. That means if there are any numbers repeated, it will not give you that. It will just give you the unique numbers. So these are the unique numbers in my array. Okay. Okay. Next is vector filtering. Next topic we would do is vector filtering. Now, what does vector filtering means? Vector filtering means if you want only a part of an array or a vector, or you only want certain elements of the vector, or you want to apply certain conditions over the vectors to return only those values, that means vector filtering. So suppose say I'm using this array now. Let us use this B array. Okay, I'm using this B array for now. Okay. Say I want to return the fourth element of the array. I want to return the fourth element of the array. I will use B4. B and 4 in square brackets. The square bracket uses the function to return the fourth element. So when I write B4, it will return me the fourth element, which is 9. Okay. It will return me the fourth element. Yeah, but how is it closed? No, TV on. It will return me the fourth element, which is B4. Okay, which is 9. If I want to return the second last element, if I want to return, if I want to return all elements except the fourth element, I want to return all elements except the fourth element. I will write B of -4. Returns all elements except the fourth element. Okay. Returns all elements except the fourth element. If I want to return the first 3 elements, if I want only the first 3 elements, I will write B of 1:3. It will return me the first 3 elements of the array. Or if I want to return the second and the fifth element, inside the square bracket, I will write C of 2, 5. It will return me the second and fifth element. It will return me the second and fifth element. Okay. This was regarding the positions. This was regarding the positions where we mentioned the positions of the values. When you mention the value, how do you mention value? Say B, where B is equal to 5. Okay. So there is no element such as 5 in the array. Okay. B, where B is equal to 5, there was no element of 5 in my array. Or B, where B is less than equals to 5. Where B is less than equal to 5. So there are 2 elements, 2 and 4. Then we have, so how am I writing? See, here it was the position numbers. Here it is the number. The array name and the array value has to be equal to 5, or it should be less than equals to 5. Or if I write B, where B is greater than 2 and say B is less than 8. Okay. B is greater than 2 and B is less than 8. So there are 2 elements, 4 and 7, which is greater than 2 and less than 8. Okay. Or I have B, where B is greater than 2 or B is greater than 7. Less than 7, sorry. B, where B is greater than 2 or B is less than 7. Or is denoted by a pipe. Okay. Or is denoted by a pipe. It is done using shift and backslash sign on your keyboard. Shift and backslash sign on your keyboard gives the pipe. Okay. So 2, 4, 8, 9, 7 are all either it is greater than 2 or it is less than 7. Okay. That is why 9 is coming and 8 is coming, because these are greater than 2 and less than 7. 2, 4 and 7 are 2, 4 is less than 7 and greater than 2 is or. Or will include everything. Okay. Whereas and will only intersect between the values. Clear to everyone? Is this clear to everyone? We again have another operator called A not equals to B. Or we will check whether how is not equal to written in R, an exclamation sign and equals to. An exclamation sign and equals to gives us not equals to. Okay. So I could write B where B is not equals to 2. Okay. So it will return me 4897. Except 2, it will return me all other elements. B where B is not equals to 2. Then there is one more operator called percentage in percentage, which works for multiple odds. Which works for multiple odds. Just write this and keep. We'll do its usage later. Just write this and keep that it is used for multiple or conditions. Multiple or conditions. Next, please write create a data frame in R. Next, give the heading creating data frame or tables in R. Okay. How do we create data frames or tables in R? In Excel, it is very easy. You have all the rows and columns made and you just feed in the entry. But here it is not that. First, you need to create each of the columns and then you need to curate those columns to get a data frame or a table. Okay. So let's create, say, name. Again, mind it, R is case sensitive. So if you're using capital, use capital. If you're using small, use small. Name, say Manali, Divya, Raghav, Vikrant, Kritika, Naman, Divakar, Astha, Sakshi. So see, these are the names I. One second, give me time. No, this line is not working. Yeah, I got it. Just wasn't working. So yeah, the name is Manali Divya and so on. I have put in name. Now I need to put in the, since to create tables, I need 2 or 3 columns. I'll put in the age of these persons. So age is a number. So I can just put in like this. Okay. These are the name of the persons there. And then we have the gender. Gender is C of P. Again, you're writing text. So please put it in quotes. Female, female, male, male, female, male, male, and female and female. Okay. Now we'll curate this. How do you name? First, give a name to your table. Say I give it as data. Okay. Data is equal to data.frame of name, age, and gender. Data.frame of name, age, and gender. See now, when you create this, this forms a table. Now, when you create this, this forms a table. Just make sure that the number of elements in all the 3 are same. The number of elements in all the 3 are same. So name, age, gender, data.frame, name, age, and gender, and then it forms a table for you and gives you a result. Okay. Now we saw to check the properties of vectors. Similarly, we'll check the properties of data frame. str of data. If you run str of data, see, it will show you that name is a character, age is numeric, and gender is a character. Okay. It will show you name is a character, age is numeric, and gender is a character. Okay. Now, similarly, as we did vector functions, we'll also do data frame functions and data frame filtering. So first, let us do data frame filtering. Data frame filtering. Now, for any sort of data frame or any table, there are 2 things, a column and a row. So when you filter, you also have 2 parts, a column and a row. The right side is always for columns and the left side is always for rows. The right side is always for columns and the left side is always for rows. When you need to filter out rows, you will write on this portion. When you need to filter out columns, you will like to write on this portion. If you want all the columns but row filtered, you will leave the columns blank. And when you need all the rows, but you want to filter the columns, you will leave the rows blank. Okay. So suppose I write my data, comma 2. I write data, comma 2. This will return me what? It will return me all the rows of the second column. It will return me all rows of the second column. It will return me all rows of second column. Similarly, data 3 comma nothing. It will return me the third row. Okay, it will return me the third row and all the columns. And if I filter data 3 comma 3, that means third row and third column. That is the intersection. Third row, third column intersection will be M. So third row, third column, the intersection is M. We have functions for taking out the first 6 rows of the data, which is called head. Head will return me the first 6 rows of my data. So it returns me the first 6 rows of the data. Similarly, tail will return the last 6 rows of the data. Head returns the first 6 rows, tail returns the last 6 rows. In default is 6, but if you want to get 2, you can write head of data comma 2. Will return you the first 2 rows of the data. Tail of data comma 2 will return you the last 2 rows of the data. Clear to everyone? Others, please let me know. Also, if I need only the first 5, if I need the first 5 rows of data, I can also write like this: data of 1:5, comma blank. This will also return me the first 5 rows of the data. Okay. You can also use logical operators. Again, this was positions. Now, if you want to use the values, so if I want to return all values, we want to return those rows whose age are greater than 30. Okay. People with age greater than 30. So I would write data where data dollar age is greater than 30. Okay. And I would need all the columns. All the columns. Data dollar age greater than 13. I would need all the columns. Okay. So there is only one person with age greater than 30. Okay. If you want data, all people with age greater than 27, say, and female. Data age greater than 27 and data dollar gender. And data dollar gender is equal to female. Okay. And you would all. So these are the 2 females with age greater than 27 and female. Okay. Then I have, if you only want all males data, you can either write data dollar gender equal to male. You can either write data dollar gender equal to male, or you can write data dollar gender not equal to female. Okay, you can write both of this. So you can get all the values of the males. Make sure you're writing the table name outside and inside. And dollar gender means indicating the column name. Data dollar gender means I use the gender column from the data table. Okay. Is this clear up till here to everybody? Last part. Okay, to data dollar, if I want all the males data, I can either write data dollar gender equal to male, or I could write data dollar gender not equals to female. Both will give me the same answer. Okay. Clear? Next part, write importing data into R. Importing data into R. Importing data into R. The first step of importing any data is to set your working directory. The first step of importing any data into R is setting up your working directory. So set WD and inverted commas. And we'll tell R in which folder is our data kept. We'll tell R in which folder is our data kept. Okay. So first, I'm setting this my working. How do I set this as my working directory? This is the path you can see above. This portion, please see on screen, everyone. This is the portion which you'll be seeing above. Control L will select your path. Control L will select your path. Control C copies your data. And Control V. Paste your and replace all the single backslash with a double backslash. Replace all the single backslash with a double backslash. Okay, this has set up a working directory for me. Now R knows from which folder the file needs to be picked up. R knows from which folder the file needs to be picked up. Now I will tell her which file to pick up. Okay, now I will tell her which file to pick up. If it's a text file, if it is a text file, you will use, first give a name to your data. Data one will be used read.table. Read.table. If it is a text file, you will use read.table. Say I want to import this water file. It's a text file, text document. So what will I write? Water.txt. Water.txt. And you will open and check your file, whether your file has a heading or not. Currently, my file does not have any header. So I will not write header equals to true. If there was a header in my file like this, let's see this linear data file. If there was a header, I would have written header. I'll show both. So water.txt, you see data one. All the 100 files is important, and R has given a natural header as V1. Okay. If you already had a header, read.table and linear data file.txt. The name is linear data file.txt. It has header, but you do not see that it has header and you imported it. What would have happened? See, the claim and payment would also have become a row instead of an header. So you would have to write header equals to true. Header equals to true for such type of file. Then you run data is equals to true. Then you see claim and payment becomes header. So this one is without header and this one is with header. You always open your document and check whether your file has a header or not. Okay. This was a text file. Next, importing a CSV file. If it is a CSV file. Okay. So for a CSV file, again, the header by default is true. For a CSV file, the default header is true. If the file does not have a header, we write header is equals to false. So for a CSV file, we write read.csv and say I have a R1 file. So R1.csv. And see, it returns me the header. Without writing the header also, it will return me the header. But if my file does not have a header, let's see which data does not have a header. Just open a file without a header. See, this children's CSV does not have a header. So when this does not have a header, I will have to write read.csv, children.csv, and you have to write header is equals to false. You have to write header is equals to false. Then only if you run head of data, since it's a very big data, I have to run head of data for. I'll just pick up the first one. See, it will give you V1. If you wouldn't have written header is equals to false, if you wouldn't have written header is equals to false, then see, 0 would have been in the header and the data would have started from 2, whereas it should have started from 0. So you have to write header is equals to false to get the correct data. Clear with everyone? Clear? This is clear with everyone? Yes, it works opposite for CSV and text file. Okay. The last one is a R data file. How to import a R data file. Okay. If it's a .r file, then let me see a .r file in my system. See, employee.r data. Let me set my directory again since it's a different folder. So I will need to set my directory again. Set WD Control V and I just set my directory again. Okay. Now we load a R data. Again, I load it into say T, or I load it in data 5. Say data 5 is equals to, I will write load, and then you write the name employee dot R data. Employee dot R data. Okay. And you run this. When you run data 5, you will see a lot of names. All these are names of the columns. Okay. And the data is data employee. And the data is data. So if you run data employee now, see, you will see over here. If you run data employee now, if you run data employee, you will get the entire table in place. If you run data employee, you will get the entire data in place. So yes, 128 is data 5. I just gave a name. And load and employee R data is a data which is there with me in my system. Employee.R data. I just wrote load employee.R data. That means it will load a R data into this system. And if I run this data and run data 5 again, so you will get a lot of names, but the first name is the name of your table, which is data employee. So if I run data employee, write data employee, I get to see the entire table, which has all the columns: salary, gender, job type, job location, age, and experience. Yes, this is having an R extension like we have for CSV. Instead of .csv, we have .r data. Clear, everyone, with this? Okay, that is it for today. We'll do other things tomorrow. Till then, just revise this for tomorrow's class and come. Not giving you all any homework to do today. Revise this and come for tomorrow's class. From tomorrow, we'll give you homework. Okay.